So number 8 is similar, except that instead of having these disks suspended by rope, you've got these chain links that are suspending each other, right? Okay, so in number 8, this is another one. I don't think I'm going to go through the whole thing, because I think once you sort of get the process, you're in good shape. It says in the figure at the right, a chain consisting of 5 links, each with a mass of 0.1 kilograms, is lifted vertically with a constant acceleration of magnitude 2.5 meters per second squared. And then the links are numbered from the bottom. Okay. So the whole thing is being lifted upwards, right? Okay, and each of these things has a mass of 1 kilogram. So which of the 5 links is going to be sort of the easiest one to analyze, you guys?
First one.
Number 1, right? Because there are only 2 forces on link number 1, right? So here's link number 1. There are 2 forces on it. There's the force on link 1 from link number 2, and then the force of gravity on link number 1, right? So that force of gravity is 0.1 times 9.8, so negative 0.98 newtons. Am I going too quick? All right. And we know the acceleration is 2.5 meters per second squared.
Yeah.
Follow? So I think what we can do is just set up a net force equals net force statement. Net force equals net force. So this mass is 0.1 kilograms. The acceleration is 2.5 meters a second squared, right? So that's mass times acceleration. Follow?
Yep.
Okay, and that's got to equal our total force, which is the force on link 1 from link 2 plus negative 0.98 newtons. And solve for it. Follow? All right. And so you end up getting a number that was on the answer key and is 1.23 newtons. Good? All right, so let me pause there for a minute. Are there problems with what I did there? Okay. Now, as you work your way up the chain, you kind of repeat this process. So, let me do this. I said, let me do this. So, similar to number 7, you kind of start at the bottom and you work your way up. So now if I look at link number 2, what forces are there? Well, there's the force of gravity on link number 2, which is another negative 0.98 newtons, right? What other downward force is on it, you guys? The force on 2 from link 1, right? Which is equal and opposite to this. And then there's an upwards force on link 2 from link 3. So again, net force equals net force, and you solve for the missing force. Follow? So, am I going too quick? Are we good? Sarah, you okay back there? I think you were the one that asked about this. Are you okay, or did I?
Yeah.
You sure?
You can tell me.
Yep. Yeah. And anytime you guys, if I stop too soon, tell me. Okay, so let's see. So now I can set up this. So net force on link number 2 equals net force on link number 2. So what mass should I use here, you guys? Point 0.1 again, right? So 0.1 kilograms, because that's the mass of link 2. Our acceleration is 2.5, right? Isn't it?
Yeah.
Okay. And that's got to equal negative 0.98 minus 1.23 plus the force on 2 by 3. And solve that. So you're going to get 0.25 plus that other garbage, and it gives you 2.46.
Instead of subtracting the force on link 2 from link 1, I just kind of treated it as a system and doubled the mass.
Yep, and I was about to say that. Yep, so that, yes. All right, so everybody good up to there? All right, and then the other thing you can do is what Josh said. And so it's funny because, so remember how we decided there are 2 ways to do number 7? Right? Never mind, you guys don't care. Sorry, I'm getting tangled up in my head. I appreciate that.
Well, what is the other way?
So when we did number 7, there were 2 ways to do it. You can, where is it? So when I did it, I first of all looked at block C,
Yeah.
and then I looked at C and D combined, and then I looked at B, C, and D combined,
Or
right?
you could just
And when I did that, I think it was Sebo said, can't you look at the blocks individually,
Yeah.
right? So because you guys said that, when I did number 8, I thought, I'm going to look at the blocks individually. And then Josh said, I looked at them. So there's 2 ways to do these. All right. Are we good? All right. The other way to think about it, Josh's way actually makes some sense because look, each chain has to lift one more link, right? Like as you go up, each link is lifting one more link than the one below it, right? And as a result, it needs that much more force to cause that extra mass to go up with the same acceleration. So that's why the forces just go up by 1.23. So the answers are 1.23 plus 1.23 gives you 2.46, plus 1.23 gives you 1.69 or whatever it is, etc. 3.69, whatever. Follow? Are you good if I stop there, or do you want me to keep going? You sure? Okay. Can I what? E. E says, find the force F on the top link from the person lifting the chain. Well, so if you look at the whole system, the whole mass is 0.5 kilograms. Right? So to do E, so here's all 5 chains, right? Chain links, rather. So the force of gravity on that is going to be 0.5 times 9.8, which is negative 4.9 newtons, right? Good? And then there's an upwards force from the person lifting it. And then
Oh, and then you use the acceleration.
and then you just do net force equals net force. And solve, yeah. Good? Everybody good? All right. And then E, what's the net force on each link? Well, they all have the same mass and they all have the same acceleration, right? So they all have the same net force of 0.25. Just mass times acceleration. Good? All right, problems on 7 or 8? All righty. Number 9, was that on our list? The